When an AI system is reviewed, the key question is simple. Can you prove every major risk is controlled? In this capstone, you'll connect risks, regulations, controls, and evidence into one audit-ready compliance map. You've already built the pieces: AI inventories, privacy obligations, NIST CSF functions, integrated controls, and audit evidence. Now we'll bring them together into one capstone mapping package, using the scenario from topic 6.1. The capstone is a traceability package, not a stack of separate documents. A risk begins in the business context and data flow, then connects to privacy or HIPAA analysis, the control matrix, NIST CSF mapping, and monitoring evidence. For each material risk, reviewers should be able to see who owns the control, whether it is implemented, how often it is tested, and where the proof lives. The integrated risk register becomes the single source of truth for AI risk. Each entry should define the scenario, affected assets, relevant regulations, likelihood, impact, inherent risk, existing controls, residual risk, evidence, and accountable owner. Its value comes from consistency. When privacy, security, bias, model behavior, PHI leakage, prompt abuse, and vendor risks use the same scoring criteria, leaders can compare them, prioritize remediation, and confirm that every risk is tied to real controls. To keep the register clean, use a taxonomy that separates risks without disconnecting them. Privacy covers how health information is collected, used, retained, and transferred. Security focuses on unauthorized access, prompt injection, exfiltration, and weak controls. I risk addresses bias, hallucination, drift, explainability, and over-reliance on outputs. Operational and vendor risk covers outages, rollback failures, contract gaps, and monitoring weaknesses. This structure helps prevent double counting while making sure no major risk category is missed. A strong risk statement links evidence to consequence. Start with the condition. What is true in the system, data, model, workflow, or jurisdiction? Then name the event that could happen. Finally, state the impact and who or what requirement is affected. Instead of AI privacy risk, write, because customer prompts containing health data are logged without retention controls, unauthorized access may expose sensitive data, resulting in GDPR noncompliance and harm to EU users. Privacy risk mapping starts by following sensitive data through the AI workflow. PHI can appear in prompts, vendor feeds, embeddings, logs, analytics, and generated outputs. At each touchpoint, connect the risk to required safeguards: de-identification, access control, encryption, retention limits, monitoring, and output filtering. This creates a traceable link to HIPAA, GDPR, and contract obligations, supported by evidence such as data flow diagrams, access records, encryption settings, and audit reports. When AI influences people's outcomes, name exactly what it produces: a recommendation, score, classification, triage result, or fully automated decision. Then trace where bias can enter, from training data and model features through deployment and feedback loops. The governance response should match the risk, using explainability, fairness testing, monitoring, human review, and escalation. Evidence matters here too, including DPIAs, model cards, validation reports, and records showing how concerns were reviewed. AI risk mapping should treat prompts as an attack surface, not just user input. A user trying to extract PHI after a model update connects prompt abuse to access control, monitoring, and incident response. Insider misuse creates another path. Privileged users may query sensitive data, alter configurations, or manipulate training inputs. Rollback risk asks whether teams can safely return to a known good version. The supporting evidence is practical: logs, access reviews, registry records, approvals, and tested recovery results. Governance also has to extend beyond your own environment. Start by identifying every vendor that touches sensitive data: cloud platforms, model APIs, labeling teams, analytics, security tools, and support systems. Then connect each vendor to the right obligations, such as BAAs, DPAs, sub-processors, residency commitments, breach notice, and audit rights. Keep the evidence current through onboarding reviews, periodic reassessments, SOC2 or ISO reports, questionnaires, risk ratings, and signed agreements. The compliance control matrix is the translation layer between what the law requires and what the organization actually does. Each obligation or risk is tied to a control objective, then to technical and process controls with an owner, frequency, status, and evidence source. The goal is traceability. A HIPAA, GDPR, or NIST requirement should connect cleanly to preventive, detective, corrective, or governance controls, and every high-priority risk should have proof that the control is operating. Compliance mapping is about finding shared control objectives, not building three separate programs. HIPAA emphasizes safeguards for protected health information. GDPR adds privacy duties like lawful basis, transparency, rights, minimization, and transfer controls. NIST CSF organizes the same work into governance, protection, detection, response, and recovery outcomes. A control like access review can satisfy all three, limiting PHI access, supporting GDPR security accountability, and demonstrating NIST Protect practices. A control matrix becomes useful only when each control has a real operating model. Name the owner who actually performs or governs the activity, not just the nearest department. Define the cadence, continuous, per release, monthly, quarterly, annual, or event-driven. Track status honestly from plan through tested and remediation. Finally, write the test procedure and pass-fail criteria. That is what turns a policy statement into evidence an auditor can evaluate consistently. The review file is proof, not paperwork. Each artifact should show that a control exists, works as intended, and has been reviewed recently. Include governance, privacy, security, AI model, incident, vendor, and training evidence. Tag every item with its control ID, risk ID, owner, date, source system, and retention rule. Before sharing the package, test it like an auditor would. Complete, accurate, current, confidential, and easy to verify. You now have the core package for AI compliance mapping: a risk register to surface exposures, a control matrix to connect obligations to accountable controls, and an evidence package to prove design and operation. Next, you'll use these artifacts to find gaps, prioritize remediation, and build a practical roadmap.